Claire Scanlon. I am a process development scientist, and I'm here today to show you a Vmax constant pressure test. A Vmax test is used to size sterile filters and some pre-filters. Vmax is the maximum volume that you can put through a filter device at 100% plugging. And the Vmax value can then be used to give you a minimum area requirements for your filter and for your scale-up processing. In our setup today, we have a 5-liter pressure vessel. Our air source is house air that is regulated by a separate regulator. You can also use compressed nitrogen or any other air source, just to ensure that it's properly regulated. We also have our test filter device, and what we're using today are OptiScale 25 filters. These are 3.5 square centimeter filter devices that have both the membrane filter and the support material within the device. So you don't have to manipulate or add anything or put together any holders. You simply can use this, plug and play. Just use it and go. If you don't have OptiScale 25 devices at your disposal, you can also use a 47 millimeter disc holder. A 47 millimeter disc holder, with that, you just have to ensure that you have support material and your membrane filter in the correct orientation, and then you put the holder together yourself. So there's a little more room for error with the 47 millimeter disc holder than an OptiScale 25 holder, but both devices are scalable to large scale devices such as a 5-inch, a 10-inch, a 20-inch filter. We'll also be using a disposable setup. So for this, we'll be testing a sterile filter at 10 psi. For a lot of process intermediates or pre-filters, we typically will test between 5 and 10 psi. Most common is 10 psi. This silicone tubing is rated for up to 20 psi, so it's suitable for this kind of testing. For final formulation fluids, which tend to be more viscous or adjuvants for vaccine processes, we do recommend running it at higher test pressures. And for those, we do recommend not utilizing this silicone tubing or other more suitable tubing that can withstand that higher pressure. So we have our process fluid in the 5-liter pressure vessel. We have a pressure gauge on both the pressure vessel and on the upstream side of the filter. This isn't necessary, but in some cases there is some pressure drop or pressure loss in your setup, and so it's nice to know what the pressure is at the exact inlet of your test device. So the first thing that we'll do is we will pressurize our pressure vessel. So the air has been regulated to 10 psi, and we're going to wait till we can see the pressure gauge reach 10 psi on our pressure vessel. The valve to the inlet of our device is closed while we wait for this pressure to reach 10 psi. Once it's reached 10 psi, we can ensure that we open up this valve, and we have our vent open as well. We need to open up the valve to actually get it open as well. So right now we are venting the filter. And so it's very important that we vent and release any air from the upstream of the test device, because these are smaller in area. If there's any air on the inlet side, you're not utilizing all of that membrane area, and your results may not be very accurate. So once you see any air bubbles purge from that line, you're going to tare your balance. Your balance is going to be measuring your filtrate volume or mass with respect to time. So we also have a timer available. So once we have both at our hands, we're going to open up the downstream side, which is clamped with a hemostat with the vent open to ensure that you're venting fully. We're going to open up that valve. We're going to close the vent valve, and then we're going to press start on our timer. This test we typically run for 20 to 30 minutes or until your process fluid is done, until there's no more remaining, or until you see 90 to 100% flow decay. So at certain steps in your process, you're going to see more plugging or fouling than other steps. Also, for some process fluids, you may not see any fouling. For buffers, for instance, you don't see much fouling. In that case, we would run the test for about 20 to 30 minutes, and that would give adequate trial loading that you can then scale up to an adequate process loading. We recommend taking volume or mass measurements every 1 to 2 minutes for that 20-minute time frame. As you can see at the beginning of the test, this is just water, so you can see that the process fluid or the filtrate is flowing pretty evenly and pretty quickly. As your process fluid, if you have a plugging stream, is plugging that filter, you will see a decrease in the flow rate from your filtrate side. At 100% plugging, there is no more dripping or no more volume or mass coming out of that sterile filter filtrate. At the end of your test, you want to close the valve to the inlet of your filter. You also want to close the valve to your pressure vessel and release the pressure and depressurize your pressure vessel. Now you have time and volume measurements for that 20 to 30 minutes or however long it took until your filter plugged. To determine or calculate Vmax, you use the gradual pour plugging method. And that is the reason why you can run a test like this for 20 to 30 minutes when in some cases your large-scale process could take 2 to 3 hours. Because it's based on a model, you can extrapolate at the degree of plugging that you saw in your small-scale test and extrapolate that to 100% plugging. You can do that by plotting T over V, or time over volume, versus time. If it does follow the gradual pour plugging method, that plot will be linear. If it's not linear, then other models may apply, and you can contact your account manager or local PDS that can better explain those models to you. If it is linear, you can find your Vmax, or the maximum capacity at 100% plugging, by finding that trend line for the line. 1 over the slope will be your Vmax, and 1 over your y-intercept will be the initial flux. For non-fouling fluids, the initial flux is very critical, as that is what it will determine your filter sizing. This is a Vmax constant pressure sizing, and thank you very much.